Have you ever really stopped to think about the ground you walk on every single day? Yeah, we call it dirt, maybe soil, and that's about it. But what if I told you that right beneath our feet, there's this hidden world with an absolutely incredible story to tell? Well, that's what we're doing today. We're going to put on our detective hats and dive deep into this geological mystery to uncover the secret life of soil.
So what is that story? I mean, where does soil actually come from? It doesn't just appear, right? It's the product of these epic forces, incredible chemical reactions, and journeys that can span millions of years. And to understand it, we've got to start with the most basic clue of all. You know, at its heart, the formula is surprisingly simple. Soil is just a combination of tiny rock particles and organic matter. Pretty straightforward. But the real mystery, the really fascinating part, is how you get from a solid boulder to, the fine-grained stuff you'd find in a garden. And that whole process kicks off with something called weathering. And that brings us to our first little case file. So, take a look at this. When rocks decompose because of things like oxidation, think rusting, or hydration, carbonation, and even acids from plants, what do we actually call that process? Is it physical, biological, chemical, or mechanical weathering? What do you think? If you said chemical weathering, you nailed it. This is our first huge clue. See, rocks don't just get smashed into smaller bits. They are chemically unmade, literally transformed at a molecular level by the air and water around them. It's this super slow, totally silent, but unbelievably powerful process. So really, there are two main culprits in this whole story of making soil. On one side, you've got physical weathering. That's kind of the brute force method, right? Think of rivers grinding down stones for centuries, or ice freezing in a crack and splitting a rock wide open. But then you have the more subtle one, chemical weathering, which we just saw. It dissolves and actually changes the rock itself. And both of them, they work together to create the raw materials for soil. Okay, but just making the particles, that's only the beginning. Soil is actually part of this massive, planet-sized recycling program called the geologic cycle. So what's the right order for all this to happen? Take a look at the options here. Which one of these sequences correctly describes the life of a piece of soil?
And the correct answer is D. It all starts with weathering, where the rock is broken down. Then, those tiny particles are transported. They go on a trip. Eventually, they get deposited somewhere new. And over eons, with immense pressure, they can be pushed back up and reformed into new rock in a process called upheaval. It's a journey that literally never ends.
Let's think of this journey in 4 epic acts. Act 1, weathering, where the rock is broken apart. Then comes Act 2, transportation, where wind and water carry those pieces on a grand adventure. Act 3 is deposition, where they finally settle down. And finally, over millions of years, they can be reborn as new rock through upheaval. Just think, every single grain of sand has lived this incredible story.
All right, let's zoom in on that transportation step. Most soil travels, it gets around, but some just stays put. And that brings us to our next question. Which of these forces, is it glaciers, water, or wind? Which one is responsible for creating something called residual soil?
This was a bit of a trick question. The answer is D, none of these. And the clue is right there in the name. Residual soil, well, it resides right where its parent rock weathered away. It's kind of the home body of the soil world. It literally never leaves the nest.
So here's the bottom line. We've got 2 main categories of soil. Residual soil, which, like we said, stays put. And then there's transported soil, which gets carried away from its birthplace by all the forces of nature. And those forces, well, they're the next characters in our story. All right, let's track some of these traveling soils. First up, when soil is picked up and dropped off by rivers, we call that alluvial soil. This is the secret sauce behind the world's most fertile farmland, like the legendary, rich soil you find along the Nile River Valley. Now, if those same particles end up settling in the calm, still waters of a lake, the soil it forms is called lacustrine. And this stuff often creates these fine, delicate layers over centuries, telling the whole history of that ancient body of water.
And when the journey finally ends in the Great Big Ocean, the seabed gets coated in what we call marine deposits. Something like marl clay, for example, is basically a souvenir from an ancient sea, formed from the shells of countless tiny marine organisms.
But hey, water isn't the only taxi service around. Wind creates what we call aeolian soils, like the huge, dusty loess plateaus in China. I'm talking about fine silt that's been carried for thousands of miles through the air before settling. Then we've got the real heavy lifters, glaciers. These things literally carve up the land, and when they retreat, they leave behind this jumbled mess of rocks and soil called glacial till. They completely reshape entire landscapes.
And finally, we have the simplest journey of all, just a short tumble down a hill. Yep, that's just gravity doing its thing, creating colluvial deposits, or talus, right there at the base of cliffs and mountains.
You know, it's pretty amazing how different soils can have such similar personalities. Take bentonite clay, which forms from volcanic ash, and black cotton soil. Now, they look totally different, but they share a key ingredient, a mineral called montmorillonite. And this stuff makes them swell up like crazy when they get wet, and then shrink and crack when they dry. As you can imagine, that's a huge headache for engineers and builders.
Of course, we can't forget the other half of our original formula, the organic matter. This is the living, breathing part of the soil. It ranges from a simple organic clay mix to stuff like muck and peat, which are these super rich, fully decomposed materials you'd find in a bog. But really, the star of the show is humus, that dark, crumbly, partly decomposed material that gives topsoil its fertility and, well, its life.
Okay, you ready? It's time for our final piece of detective work. And this one is very specific, so pay close attention. What do you call those alternating thin layers of silt and clay that get deposited in glacial lakes, where each pair of layers represents a single year? Take a good look at the clues.
The answer is varved clay. And this is honestly one of the most beautiful stories that soil can tell. See, in the summer, when the glacier melt is high, a thick, light-colored layer of silt settles in the lake. Then, in the winter, when the lake freezes over, a really thin, dark layer of superfine clay settles out. Each pair of these layers is a perfect record of one single year. It's like a geological calendar, or tree rings for the Earth.
So, the next time you walk outside, just remember, you are not walking on plain old dirt. You're walking on a library. Every single layer, every particle, is a page in a book, telling a story of fire and ice, wind and water, a complete history of our planet, and it's right there under your feet. The only question left is, what story will you find?